my name is indeed Tom Kerkhove. I am here to bring you through the afternoon depression. So I have a session with a lot of slides and demos, so I hope I can keep you awake. So for this talk, I will use Contoso as a reference example of a journey that they went through. Of course, it has to be Contoso because that's the default company. What are they doing? They provide industry-leading APIs to sell products. They allow you to list all the products, create an order, and get information about your shipping. Of course, they don't do the shipping themselves, so they use a vendor that does this, where they also have to notify Contoso, about the process of the shipments. So they need a webhook, basically. So Contoso is a startup. They started very simple, and they created a monolith on Azure App Service. On that API, they have three main blocks, which is products, orders, and shipments. The shipments piece is mainly for the third party, and the other ones is for the app developers. So this was very easy to build as an MVP and to show the business that the idea is worthy to invest in more. And it is an easy way to also start making money because they can give the API to their end users. However, there were some problems with the current approach. Security is poor because they have to implement everything themselves, if they even did it. The application developer experience was also poor because if they were lucky, they had a Swagger UI. If they were not, they just had to figure everything out themselves. And there's no governance, nor the company has no idea who is using the APIs and how much. So this is where Azure API Management came in the picture for them, which Fernando just explained in detail. But basically, API Management gives them the three blocks, which is a developer portal for their application engineers, so they can explore what the APIs are, the documentation, etc. As a company, they get a control plane where they can manage the APIs with various tools, and then there is the data plane gateway. This is where the customers and the third party send all the requests, which then get routed to various destinations, either on-prem, on Azure, wherever their services are. In this case, it is app service. So by using API management, they very easily can add authentication, such as Fernando showed earlier. They get API analytics, which helps them understand which company is using the APIs, how much, and the developer portal that I mentioned. So if you have a look at the new approach, basically, API management is the facade of everything that they expose. So nobody goes directly to their app service instance anymore, and they have this central place for their API landscape. Behind the scenes, then there's the web app that we discussed. So it's purely a proxy in the middle to help route the traffic. So going forward, in API management, you have to author your APIs and how you expose them. So to get started, they create one product, which is a way to expose your APIs to your customers. And as part of that product, they have one logical API, which is the Contoso API, which is based on the OpenAPI specification that they had. This is a very typical approach to get started, because now they have that dev portal, they have the analytics, and they basically just show the facade to their customer. The problem, however, is as their company becomes more successful, they have issues scaling that monolith because it is one big chunk. And also, if they want to do separate releases between these three areas, they are tightly coupled, resulting in big bang releases. And then, of course, you also have the requirement to only use one technology, and they all have to mutually agree on that, which is not ideal for their situation. For example, some might want to use Python instead of .NET. So then somebody came up with microservices. Maybe we should use microservices. So before I explain how they went there, the main question is, well, what are they actually? So depending on who you ask, you'll get a different answer. But the main idea is basically you take the big block and you start carving out smaller pieces, which you can then drive by smaller teams, release at their own cadence, etc. This is simpler in the sense that you have this autonomy across the teams. However, that also means that you need to reconsider your architecture, because the order service needs to know the information from the product catalog. Is this order that has been created actually for a product that we offer? So you start influencing things as well. The main question is, how do you get there? Like, we already have this monolith. We cannot just throw this away and replace it with microservices. So what they decided was, let's split these services apart. And while we're doing so, let's use containerization to have these separate services, which we can also more easily run locally. So that if I work on the order service, I can just pull in the image from the other team. After using app service, they are also a fan of using platform as a service, meaning they just deploy their app. If they want to scale, they just take the slider and go to the right. If they need less, they go to the left, and they just pay for that. They don't have to be looking at the VMs, installing software or whatever. Just deploy the app and scale it as they want. So they basically decided to use Azure Container Apps, which is a PaaS service for running containers in Azure. And by the fact that they already use containers, they still have the escape hatch to something called Kubernetes if they really need to have that cluster technology available. So basically, to summarize, they split the monolith into multiple services. They will containerize them, but use a PaaS service. However, they do not have the lock-in to that technology stack. So they first decided, before we actually change the monolith, let's start with a logical separation. And this is where your API gateway can help as well. So initially, they had this set up with one product and one API, but instead, they decided to do the split in API management first, which means they can get a feel of their business domain. They can start authoring the APIs as how they want to without changing any code or whatsoever. They can experiment on this front. So we now have an API per, let's say, microservice, but we still have the old one because we already have customers using that live in production. However, we also have a new product, which is called Corito Webhooks, because the audience of our APIs has changed. The third-party vendor only needs access to the shipment API, and the app developers need access to products and orders. So that's why we also make the distinction there, so that the third party only has access to that API. Let me skip that one. So doing logical separation is nice, but if they see that this becomes valuable, how do we start splitting things internally? This is where things might seem tricky, but actually it's very easy to do that. So what you end up doing is basically you deploy your new container apps next to it, and in this case also a function for the shipment notifications next to your monolith, where you use the policies in the API gateway to just introduce traffic routing, which is actually fairly simple to use, which means you have everything deployed next to each other. You can apply the policy so that traffic gets routed. But if it goes wrong, you just rip out the policy again, and all traffic goes back to the monolith. So that gives you some control on how you can load balance, but still have a safe way to do that. So let me quickly show you how that is done. So I have here an API management instance, which has the 4 APIs that I was 5 APIs, yes, and that's readable. So here we have the monolith API and then the new microservices. So for example, here we have the operations that we want to experiment, where we want to send half of it to the monolith of the traffic and other half to the microservice. So what we can do is Azure API Management has a whole list of policies. And we actually nowadays have a documentation page for every single policy. So this is now much easier to find. So we'll use these policies to route the traffic. To show how it works, I also added some default headers here so that we can see what is the backend URL that we're calling, what is the gateway that we're calling, and what is the region of the gateway, which I'll come back to that later on. Also, I don't want to leak my internal technology stack, so I'm removing the default .NET header here. So let's route some traffic. First off is we will change the get all products endpoint and apply a new policy. Let's take a bit more space. So before I do that, I already, oh boy, that's not good. So I already created, what is it? Okay, this one. Okay, that's good. So I already have this configured in Postman here. I'm just doing a get on the get all products. I get a nice response back. And here you can see I am calling app service directly with my gateway in North Europe, and this is my service name. So I will now, of course, cheat and copy the policy, because that's too much to type. So what I added here is a policy that basically generates a random code between 1 and 3, where 3 is not inclusive, so basically 50-50. And then I have a simple choose policy that basically says when that value is 1, don't do anything. It will use the monolith that is already configured. When it is 2, change the backend service. And here I am using a reference to a backend resource which is mapped to container apps. If for some magical reason it is not 1 or 2, just return a 500. So I will save this and then, just for sake of the demo, show you here. I have a list of these, but in this case, you can see this here is Azure Container Apps. So now if I start sending requests, you can see that the first one actually already went to Azure Container Apps. If I do another request, it's the same. Now it was the monolith, etc. So with a simple policy, I am now trafficking requests between old and new. You can profile performance. You can see if there's any bugs in your monolith, and then take it from there. So in the end, you'll hopefully notice that your new approach is working fine, and it's safe to go to that new approach. So in the end, you'll get rid of this 50-50 balancing or whatever percentage you want to use, and you'll just change the monolith logical API to send traffic to all new microservices. And that's all nice, but then, hey, we can't use the cloud, so now what? And I'm pretty sure that maybe raise of hands, how many people have things on-prem that can go to the cloud? That's what I thought. This talk. So if we have a look, this is a typical API management scenario where we have API management in the cloud. We have some systems in other clouds or on-prem. For example, BizTalk, where you can call API management, but in the end, what will it be doing? Send your requests to another place, which does not really make sense if you even can do it in terms of networking or security. So that's where our self-hosted gateway comes in. Who has ever heard of the self-hosted gateway of API management? Okay, more than I expected. So what is self-hosted gateway? Instead of going to the cloud, what we'll do is we'll bring the gateway to you, where you can just deploy it where your application is. Self-hosted gateway will connect to the cloud for the configuration. It is a federated solution, but if you cut the network connectivity, it will still be running. So you can run it for 20 days, 30 days longer, and your traffic will not be impacted. However, you'll be running an outdated configuration. And then instead of calling it cloud, you just call that local gateway, which then talks to your on-prem system or system in another cloud. You can also, of course, do this inside of Azure, for example, on AKS, because you want to host everything inside the cluster. That's also a viable option. Yeah. So what is the self-hosted gateway? It is a functionally equivalent gateway, similar to managed gateway, but there are some gaps between both of them. So if you want to know the differences, we have a nice documentation page explaining the differences between consumption, dedicated, and self-hosted gateway. From the top of my head, self-hosted gateway has OpenTelemetry support, Dapper support, HTTP2 support, but it does not support GraphQL that Fernando was showing. So make sure to know what the differences are, but most probably it is still a viable solution. It supports REST, SOAP, and WebSockets today. It is a Linux container image as well, and you have to run it. That's very important. We give you the container. We give you the connectivity to the control plane. We'll make sure control plane is up, otherwise you can call us. But then it's up to you. All you need to have is the outbound connectivity so that it can basically call home to know the configuration. And you can deploy it practically anywhere that can run a Docker image. So Doc is cheap, so let me show you how you can do that. So in the portal, you have a section here which is called gateways. This is basically a self-hosted gateway. And this is also very important, the unit of billing. So if I create one resource here, that is, I think, $1,000 in premium. Developer, I guess the same. But that's the cost. That you know how much it's going to cost. If you run one instance or 1 million, it's the same cost regardless of how many traffic you pump through it. Okay? So you also have that predictability. So let me call this gateway integrate stage, and then I will basically create this. Good to know is here you can also see how many are connected. I have this other one here which shows I have 3 live instances that are connected. So that's important to know. It's connected to the cloud. You might have 10 which are disconnected, which means they're not impacted specifically. They're just not connecting to the control plane. So I can select the self-hosted gateway. You have the same Azure Monitor metrics in the portal if you've enabled them. And if you go to deployment, basically you need to have a gateway token to authenticate to the configuration API. So all you need is just here. So let me copy this and just create a new file. Self-hosted gateway.config. Let me copy this command. So I will use the new gateway from today, which says just G8. Let me change the port. Actually, and I'm in the wrong folder. No. It's hard to type when people are watching you. Where did I put it? Okay. It's hidden. Deploy API. I don't know why I put it here. No. Oops. What did I remove? Yeah. Come on. You just go to that folder and be lazy. Here we go. There. Oh, okay. Yeah. Oh boy. See, that's what you get when people watch. So I already pulled the image because conference Wi-Fi's are unreliable. But if I do Docker logs, you can see at the top, of course, it is a container, so it has to have ASCII art. So here we are, which is a nice reference to the codename Sputnik. It's starting up. It also shows all the available policies, because that is another difference. And basically, at the end, it's now pulling in the configuration, and now it's ready to serve. So if I change this, localhost 8080, and now, we get a 404. Why is that? Well, as a security measure, by default, it's not exposing anything, because you have control on what you want to expose. So if I just add this API in the control plane here, you'll see that, first of all, it's processing my request, which returned 404. So you get access to all these logs because you run it. And then you see it pulled in the new change, and now it works. If we check the headers, we can see it was talking to the cloud. The region is integrate stage, which I specified, and it's talking to my APIM instance. And that's how simple it is to get started. Said no one ever. So it comes with shared responsibility, right? So we give you the image, we will patch it, we will also do security patches, believe me, there's a lot of them, and we have an SLA for the control plane. And that's where it stops for us. Then it's up to you. You need to scale it, you need to keep the image up to date, you need to make sure your network has the connectivity, etc., etc. So this is not a walk in the park, right? If you can use managed, please use managed and let us do all the hard work. Because that also means if we do patches, you need to become aware of them. You need to roll it out through all your regions, through all your stages, test it, etc. You also need to do capacity planning, for example. We give guidance on what you should use, but we don't know your network. We don't know your nodes. So it's up to you to use tools like Azure load testing to know if it will meet your demand. So coming back to managed versus self-hosted, imagine you want to deploy these microservices to Kubernetes. One approach is you use managed gateway and you expose these services outside of the cluster, outside of your network boundary, so that it is accessible, which is not always ideal. So you can take self-hosted and deploy it inside the cluster, so it is reachable. And here you also see the difference with monolith versus microservice. Order service also needs to talk to shipment service. Do they talk directly? No, they should go through your API gateway, so that if shipment service wants to change something, they have the capability of an API gateway as well. This also means that if you have a BizTalk server running, for example, which has an HTTP or SOAP endpoint, self-hosted gateway can also help you phase that out. Meaning, if you expose that BizTalk service through your API gateway, what you can do is basically build the new shipment service. Here it is Kubernetes, but it can be anywhere. And also do that traffic routing so that when you know the new service is working, you can start decommissioning out the BizTalk one because everything's going through the API gateway. Of course, in this example, self-hosted gateway runs on Kubernetes. Does that mean you need to use Kubernetes on-prem? No. You can use any Docker-capable system. So let me quickly show, I think I'm running out of time, but let me show you a little bit of this. Yep, make sure I show everything. So let me get rid of this. So I have already installed, let me go back here. So in the deployment tab, you also have one for Kubernetes, which is YAML, of course, it's YAML because Kubernetes. So you can take this, but note this, before deploying to production, here is our production guidance. Don't take this and deploy it to production. It's not good for production. We have, however, a Helm chart. So the Helm chart, along with release announcement for Helm and container, is on GitHub. So actually, everybody can send pull requests to our Helm chart. And you can see the Helm chart a bit as production ready-ish, meaning we have knobs to turn on HA, to turn on telemetry, etc., without you having to be an expert on self-hosted gateway. So that's what I did. I did Helm install, and you can see I have a couple of things. I already have Prometheus running because cloud native. I have an OpenTelemetry collector, and I have this other self-hosted gateway, which is called Hybrid Gateway. So if I do, that's kubectl get pods, you can see everything's running, including my microservice. And I have 3 replicas of my gateway running for a while. I can show you the logs, but in the end, they're just the same. And I can call it as well. So it's important first to know, if you deploy the image, how do you know it's running successfully? Well, there's this status endpoint, which you can use to probe and see if it's up and running. So that's the first thing. Second is, for the sake of the demo, I added a DNS name to the Kubernetes service, which I can show you here. kubectl get service. So you see 2 things here. One is, the first one is a load balancer to receive the requests. So in this case, for sake of demo, it's a load balancer because I don't want to jump through networking hoops. This can be private in your network as well. And then the second one is an instance discovery one, which is another thing. In the cloud, we can just synchronize things under the hood, but now it runs on your infrastructure, so you need to help us set up synchronization across instances for things like rate limit, etc. So we will be calling this service, which is this one, and you see it works fine. However, region is the new one, but it's still calling the monolith, because in the control plane, let me go back here, because it is configured to call the monolith. And let me indicate this as well. So we're calling the products microservice. So here you can see there's nothing, there should be nothing here. Oh yeah, this is load balancing. We don't need that here. Let me throw that out. So by default, it's just going to use what's called the backend URL here, the web service one. So what we want to do now is basically say, if we're running on a self-hosted gateway, stop using that one, use the other one instead. And this is where the policies come in again. Let me explain it here in the meantime. So we actually have a very simple context property, which is called, is the gateway managed? Because now you have all these different flavors. So now you can add a logic like, if it is not a managed gateway, change the backend URL because we're running on Kubernetes. You can also use gateway.id and use, in this case, if it is hybrid gateway, use this one. If it is integrated, use the other one. So you can also be flexible there in your traffic routing. Okay, good thing it got saved. So now if I save it here, you'll see that now it called my Kubernetes service. with the same region here. Also, I added the gateway ID here, which shows it is hybrid and is managed as false. And here is also interesting. You can return the instance ID of the self-hosted gateway. So if you do a couple of calls, you should see, okay, for some reason it's always going to the same instance, but it should show you the different instances so that if you use application insights, you can also see failure per instances. Okay, I need to be very quick now. But I mentioned OpenTelemetry, so you can basically configure gateway to use OpenTelemetry, which then pumps to self-hosted gateway here, which if you use Grafana or Azure Managed Grafana, you can basically plug it into that as well. And here you see I have some health probing and somebody's trying to poke it as well. So if you send more traffic, you can use these tools if you want. And last but not least, I am a big fan of application insights, more specifically the application map. So here you can see that although we're using self-hosted, you can see all the same traffic here. And you can see this one is called on-prem cluster, which is the one on Kubernetes, which is sending traffic to the microservice on Kubernetes, and then also one to container apps. And then here you see managed is calling monolith, and this one, because I didn't remove the policy up front, also called monolith. So you get the same observability experience here. Okay, we need to rush. So why would you use self-hosted gateway? So some companies have a multi-cloud or run anywhere requirement, which is fair, but you still want to standardize on one API management solution. So this is where you can do that approach, where, for example, customers on GCP, AWS, on-prem, run self-hosted gateway, and still configure everything in API management. Secondly, companies want to use Kubernetes because that's their standard, and they also want to reduce the lock-in on the underlying platform. Other reasons are workloads are already running in Kubernetes, so why would I send my traffic outside of the cluster just to come back in? And they want to have more control, which is also fair, but that comes with more responsibilities. So, in closing, let's take a look at Contoso's journey, where building a platform is actually a journey. Your requirements will change. Your APIs will change, and you have to basically agree with the fact that things change. Small apps require small responsibilities, and as your application grows, so does your needs and responsibilities. And this is one of my favorite pictures from Martin Fowler, is you can go straight to microservices and fight the dragons on the way, or you can start with a monolith first and start carving them out as you get to know your business domain, because that takes maybe more time, but in the end, you'll have a better microservice landscape. And please don't do microservices for change of microservices, because you are not Netflix. Maybe you are in the future, but you are not today. So why use the same complexity as the big companies, which is perfectly fine. Start with a platform as a service and evolve to something like Kubernetes and maybe even beyond if you need it, because it comes with a lot of operational overhead, a lot of responsibilities and control. So run your applications on a fully managed platform and make sure that the learning curve is a lot smaller. Focus on your application and not the infrastructure. We've seen that by using an API gateway, customers will actually not notice any of it. You can start with this monolith and then split it into multiple separate applications and then make it more complicated and introduce a cluster technology if you have to. An API gateway really helps here with building that platform, and it decouples your physical APIs from your customers. And something I didn't show is that it is also a very good protocol gateway, like Fernando showed, is that today we support some protocols, But like Clemens said, is in the future there might be other ones where you want to expose gRPC or whatever, but that does not mean you have to build a gRPC service or GraphQL. You can just use one of these in the API gateway. And with that, thank you very much. And if there are any questions, I'll be outside so that Nino can start his session.